All right, there we go. Welcome, everybody, to another episode of our Labs Open Office Hour. This week, we're joined by William George, our resident everything else, expert. So you look at engineering, CAD, CPU, GPU rendering, that sort of thing. Give us a little bit about that, just in case anybody doesn't already know.
Yeah, so that's historically what I've been doing, primarily covering, rendering engines, so V-Ray, Octane, Redshift, and engineering applications like SolidWorks, Revit. We actually just had a Revit article go up this week, looking at, in fact, actually today, I should say, looking at the new Ryzen processors in Revit. Finally, it took us a while to get around to doing that. And then photogrammetry, so Metashape, reality capture, Pix4D, and then I've also ended up doing some of our stuff for like VR and live streaming systems and things like that as well, where we don't do as much testing necessarily specifically, but we have recommended systems for them.
Yeah.
And actually, my role is going to be transitioning a bit over the coming months, moving more toward the hardware side and away from some of the software stuff.
Okay.
So, yeah,
that'll be fun. Get to play around with more of that sort of thing.
Yeah.
So you mentioned the Revit CPU article. It was a finally. So what was the hang up there?
Our engineering testing is not as automated as some of our other application testing.
Okay.
So we weren't able to include it in the early stuff we did, like right when the new Ryzen processors came out, 3 months ago or so.
Right.
I think it was November. So 2 months, I guess. Anyhow, we weren't able to include the SolidWorks or Revit testing at that time, but I got around to doing that in late December, I guess. And then we got the SolidWorks article up, I think, right before the new year, and the Revit article went up today.
Yeah.
So we can't. We're in a weird situation also where we can't really move our engineering systems to those yet because Ryzen processors have not been as widely available as we would have hoped.
All right.
They're fantastic performance. I'm sure it's a combination of high demand plus, all the supply side issues going on with everything from this last year.
Yeah.
But hopefully soon, once supply for those evens out a little bit, be moving probably most of our engineering systems, not just SolidWorks and Revit, but AutoCAD and Inventor, and a lot of those should all be going over there because the Ryzen processors are just faster in single-threaded performance, which is mostly what matters for modeling and building parts and assemblies in those applications.
Okay.
Yeah,
and that's kind of a big thing, like especially the single threaded. Like I know Ryzen's kind of been comparable in the multi-threaded space for a little while. Like I think with the previous gen and now this one, obviously. But to hear the single threaded stuff coming out on top is a bit of a surprise.
It is. That had long been Intel's strong suit, even when AMD had higher core count stuff. The single threaded up until this generation of processors, Intel was in the lead. And I don't know, that's going to be an interesting fight. Intel's, I'm sure, got new stuff coming out at some point this year, so we'll have to kind of see where that goes. It may waffle back and forth between Intel and AMD being the top for a while. I don't know. Cool. But competition is good either way. So
yeah, that's neat. Right on. So I actually, while I have you here, let's until maybe soon we get some questions from the audience, let's kind of go over some of the results that you got recently.
Sure. So like I said, the most recent thing I've published is that Ryzen article. And basically, I don't know if I have a good quick graph to throw up here, but pretty much across the board, the AMD processors and the single-threaded stuff, which again is most of what you're doing in a program like Revit, were about 5 to 10% faster than Intel's Core i7 10700K and i9 10900K. Are kind of the comparable Intel chips to the higher-end Ryzen series.
Okay.
And then in rendering, which you can also do within Revit, of course, AMD's core count edge made them a lot faster on the higher core count chips. The other stuff that we've published recently, we did a roundup. It's kind of funny. We did a roundup of Metashape, so photogrammetry, using version 1.6.5, which had been the version out for several months.
Mhm.
And so we'd done all of our testing except one GPU. I think we were doing different video card comparisons. And there was one GPU we hadn't done yet because we were waiting on a sample of it, the Radeon 6900 XT.
Okay.
And so we did all the other testing done. That came in this week, and we were able to get some testing done on it. But on New Year's Eve, Metashape, or Agisoft makes Metashape, came out with a new version. So we went ahead and did the test on 1.6.5, published those results, and then I went back and updated to 1.7.0 yesterday and started doing testing. And performance is a bit different now. So we're going to be hurrying out an article. It's not going to be as comprehensive because that big roundup included the 6800 and 6800 XT and some of the other NVIDIA models. We don't have some of those available anymore, and we don't have time to go back and test every single NVIDIA model and everything. But the roundup's going to have the 96 or the 60, I keep saying it backwards, 6900 XT, and probably the 3080 and 3090 from NVIDIA, as well as just a no GPU setting, so you can see what would happen if you have no video card or not a very powerful one. And hopefully get that out maybe today, if not early next week, because there's definitely big performance differences. The AMD cards in 1.6.5 were far behind NVIDIA.
Yeah, I'm noticing that in there's a particular graph here, the park map one in particular. It's insane. It's like, we have like a graph this big, and then the AMD one is like five times longer. It's crazy.
It's quite a bit. It was quite a bit slower. And that was one specific step within the park map there. You're probably looking at the one showing like, it was basically this is the reason the AMD cards are so much slower. It's this one step. Okay. Photogrammetry is comprised of, depending on the application, anywhere from about 3 to 6 or 7 different discrete steps as it's going through and doing different parts, going from aligning the images is always the first step, trying to figure out where all the photos are, and through making them dense cloud, and then making a model and texturing the model and all those sorts. There's a bunch of different stuff. But there was one step in Metashape where the AMD cards were doing really poorly. And that is no longer the case. They now perform just fine there. So they are now on par, it looks like, with NVIDIA cards. And we'll have an updated article showing that, like I said, either this afternoon or Monday, depending on how fast I can get the last set of results. I'm running the 3090 right now. And then I think, just 38, 3090, 6900 XT, since those are all sort of in the same range, that AMD card is right between those two NVIDIA cards. And we don't have the other AMD cards to test anymore. Yeah. We had to send those samples back. So it'll be something, though. And it's good news for AMD fans and folks that might already have those. So that's coming. And then I'm also in the midst of a couple reality capture articles. Again, another photogrammetry program. That one needs NVIDIA cards. A lot of the photogrammetry programs are CUDA only. Okay. Metashape is kind of the exception to the rule there, in that it supports OpenCL stuff as well. But in reality capture, looking at multi-GPU performance, so 1 versus 2 GPUs, how much benefit do you get there? And also SMT on versus off on the new Ryzen chips. Mm-hmm. We had an article looking at hyper-threading and simultaneous multi-threading several months ago on Intel and AMD before Ryzen came out. Now we're just updating it with a look at the Ryzen chips.
Cool.
Because it is interesting. It's not super common, but some applications definitely benefit when those features that normally speed things up are turned off. Mm-hmm. So
it's cool. And I remember kind of scrubbing over that comparison, and it was interesting to see some of those comparisons, like where it did make a significant difference. Like it's shocking to see when something like that slows things down. Because you'd think like being able to kind of spread the processing out would overall give you better performance.
Yeah, it really seems to depend. Sometimes certain applications just sort of peak out at a certain core count, and then anything beyond that doesn't really seem to help. But by having more cores running, you end up with like lower clock speed, and that counteracts things. And then some programs just get worse. Like they try to spread it out, but there's enough of a penalty as it spreads out over more different discrete processes that it ends up actually hurting performance at some point, or just not getting any faster at least. So that's actually something probably we'll need to revisit in Metashape 1.7.0, but in 1.6 whatever and before, that was another place where anything beyond about 8 cores, you were better off disabling hyperthreading or SMT to get the best performance in Metashape. And reality capture is somewhat similar, it looks like. I need to compile the results. We've done all the testing, but I haven't had a chance to do all the putting together the graphs and analyzing it yet. But those will be coming. So a bunch of articles coming out, lots of little niche things. I'm kind of trying to wrap up a bunch of stuff because, like I said, my role is going to be transitioning a bit. So want to get everything that I had on my list to do done.
Just for my own, I suppose it's just popped into my head, and anybody who may be thinking the same thing, is turning that on and off, is that fairly simple, or is that something?
You do have to go into the BIOS, but it is just an on-off, enabled, disabled thing in the BIOS. So it's real easy to do. It's not something you'd probably want to be going back and forth on frequently, just because dipping into the BIOS is kind of annoying. But certainly, if you're like, hey, this is a Metashape workstation, and I've got a 16-core processor, just go turn it off. It's not going to have a substantial impact on other daily usage, like just web browsing and stuff like that. So unless you're using another application that definitely does benefit, you might as well just flip it off. There's also, you can pull fancier tricks inside Windows, like trying to set affinity for certain applications, which should do the same thing. Like if you can make sure that the program is only running on the actual real cores and not the hyper-threaded or multi-threaded cores. And then also make sure you don't have anything else running that is suddenly hitting it's potentially doable. So if you did need to try and do it, but it's a pain to mess around with Infinity, in my opinion. So yeah.
Possible, but not recommended.
Well, it all depends on what you're comfortable with, I suppose. But it's at least for the testing, it's much easier to just go in and turn it off in the BIOS and not try to mess around with Affinity and everything.
Okay. So we do have a question from YouTube. Asaf Lasberg, videographer. He asks, Intel or AMD for Pix4D? What do you recommend?
AMD, and specifically with Pix4D, the lower end Threadripper chips do really, really nicely. So Pix4D does scale well with cores better than Metashape, for example. Like I said, Metashape kind of peaks out at 8 or maybe 10 cores as far as the sweet spot, at least with SMT or hyperthreading enabled. But Pix4D will go higher. You still don't see huge benefits from like the 64 core Threadrippers, those monsters. But like the 24 core is really good. And honestly, the new Ryzen chips are good too. They're not as high a core count, but the extra clock speed they have makes it really good. So like I'd look around the neighborhood of like the 5950X or the 3960X on the Threadripper side, the 24 core, somewhere in that ballpark. Possibly as high as the 32 core. The biggest difference there is going to be on the Ryzen platform, you're limited to 128 gigs of RAM. Threadripper, you could go up to 256. So if you need that extra memory, if you're working with really, really large projects, then that would bump you more over to the Threadripper. If you're not, the top end Ryzen does really nicely too.
At around what point does that memory limit make a difference? Like,
it's a little tricky because it depends on not just image number of images, but I think also resolution. It's been a while. I did some testing. Goodness. Problem is I do so much testing. Some of the older stuff doesn't stick around in my head long enough.
I did post a link to what I think is the most recent Pix4D AMD Ryzen 5000 series article.
Yeah, that's the most recent one on Pix4D. But I'm trying to think. The projects we test with all of our photogrammetry applications range from, I think, about 50 images on the low end, which is very small, but some people do small stuff like that, up to a map that's around 800 pictures, a little shy, high 700, but in that ballpark. And if I recall, we did some testing a year or two ago now with a couple larger image sets.
Ooh.
I just can't remember if that was something we actually ended up publishing or not, is the trick. We have so many articles, I'm not sure I'm going to be able to go back and find it. But there definitely is a point at which, like, normally I think we do 64 gigs of RAM when we're testing in these, and that's plenty for the image sizes that we're working with, or the image counts, I should say, that we're working with.
Okay.
So
yeah, if you're using 64 gigs for, it says here the park map is 810 18 megapixel photos. So if you're going to be going beyond, if we're talking 128, that's a lot.
It is, but there are definitely, especially on the mapping side of things, like if you're doing a model, usually, your image count's not going to be more than a few hundred, maybe most of the time anyway, because usually a model's going to be something humanish scale. And so you might have, like one of those cool booths where they've got like 50 or 100 cameras doing something. There's neat stuff like that, but you're still probably not going to go beyond a couple hundred images maybe. But when you do maps, I mean, people do maps with thousands upon thousands of images. So you certainly can get up there. But at that point, you can also sometimes just break those apart into sections and do them in separate sections for processing so that RAM doesn't become too much of a limiting factor. And then you can stitch those projects back together afterward.
Nice.
I can't find it, but I know we did some at least internal testing with image sets around like the 2000 mark.
Mm-hmm.
And we did find with Pix4D, as you went up to some of those, what to us at least would be extreme image counts, the higher core count processors did slightly better. So basically, the more images you had, the better a high core count chip was in Pix4D. And I don't think we ever hit, though, a limit where 128 gigs wasn't enough. But you certainly can with sufficient images. So
sure. Oh, that's pretty cool. Right on. All right. So what else have we been working on here?
Let me look back.
I'm filtering by Pix4D here.
Did the Revit article, the Metashape stuff. Oh, we had some just 3060 Ti performance stuff in GPU rendering.
Yeah.
Nothing terribly surprising there. All of the 3000 series NVIDIA cards do really well with the GPU rendering engine. So Octane, Redshift, the GPU side of V-Ray, that sort of thing. The 3060 Ti in particular tended to be on par with or better than the 2080 Ti. So, I mean, that's that's a $400 card, $399 that the 3060 Ti is supposed to be.
Yeah, I think that's the MSRP. Yeah,
beating a $1,200 card from the last generation, matching or beating it, depending on the engine. So that's pretty impressive. Granted, it does have a little bit less VRAM at 8 versus 11 gigs, but still a very good showing.
Yeah.
So that was cool to see, and
I'm loving seeing how it's comparable to the 3070. Like it's only just a little bit slower.
Close. It's it really depends. It seems closer, I think, in a lot of the like if photogrammetry, for example, it's not far off. And in some of like the photo and video editing things, rendering is usually the best place to see the differences like between GPUs. So it's more stratified there, but it's not super far. I mean, probably within 10%, I think, most of the time. I think V-Ray showed the biggest difference at closer to like 15% less than the 3070, but yeah, not super far off. And one thing though that I always find funny, like I'll see people look at it and be like, okay, $400 card versus $500 card, 10% performance difference. We'll just go with the cheaper card. And that certainly can be valid, especially if you're just buying a new card and you already own the rest of the hardware. But if you're buying a brand new system, that $100 might only be a 3 or 4% difference in the price of the system. And now you're talking about spending 3 or 4% more and getting maybe 10% better performance. Suddenly it does make sense to go with the higher end model.
Yeah.
So you should have to kind of keep that in mind. If you're looking at buying or building a whole system, the individual price differences, you want to look at the price delta within the whole system, not just for the part.
Right.
Same thing with CPUs too. A lot of times people will be like, well, it's $100 more for the CPU. It's only 10% faster. Okay. Yeah, true. But that $100 is a tiny amount of a $5,000 or $4,000 whole system.
Right.
And suddenly is worthwhile.
Yeah. And I like pointing out too, that $100, what does that mean in time? Like that 10% performance difference could save you over the course of a month, an hour. And that hour is $1,000 to you. And so that's a consideration as well that I think a lot of times gets confused. I know there's a lot of enthusiasts and gaming related stuff out there. And so that's where sometimes the price to performance tends to lean more toward the price part. But when you're talking in a professional setting, you got to think about how much those minutes cost.
Yep.
And that can be a huge deal.
Yeah, certainly.
Yeah. Yeah, I'm looking at these, and yeah, you're right. It does look like pretty significant difference here in V-Ray, at least just in this roundup article I'm looking at. That seems to be the biggest spread. But man, I'm just every time I'm more and more excited about this current generation of hardware has been just tremendous. It got a little boring over the last couple of years. Intel's performance generation over generation kind of plateaued, and everybody was kind of holding their breath for this release from AMD, and I'm super stoked to see them punching right up there now, and it's really cool, very cool, despite the stock issues and things like that. But it's once all that levels out, man, everybody should be very, very happy.
I think so.
Yeah. Oh, Matt comments, gaming is all about making things look better, so 10% isn't much. Productivity is all about how much time is saved, and saving 10% of your time is huge. Exactly.
Yeah. I don't know. Competitive gamers, it's not so much about making things look better, though. It's about those frame rates and getting the smoothest stuff. My brother used to play. He did MechWarrior Online competitively. So he was on the championship team a couple years in a row for that. And it always used to bug the heck out of me. He'd play lowest quality settings just to get the highest frame rate. I'm like, you're supposed to be enjoying the game and how it looks, and I'm there with max quality settings and he's there with the lowest and kicking my butt.
And not to go off on a weird tangent though, there is a significant amount of data that shows those higher frame rates and higher refresh rate monitors make a significant difference in those competitive edges. It's
especially if you're a good player that can feel that difference. Yeah,
that's pretty cool. Let's see. All right, let's see. We got we looked at Agisoft. We got the Metashape. We got the let's see Revit. What else are we looking at here? We got SolidWorks. Let's see Octane Render. Oh, what? I'm curious, William. What set of software do you enjoy testing the most?
That's an interesting question. I'm not sure. So as far as enjoy testing goes, a lot of our testing is automated to the point where we're not really doing anything other than telling the computers to start the testing.
Okay.
The engine, like I mentioned earlier, the engineering software, we aren't at that point. There's for a variety of reasons, but I think if you were talking about like what's most interesting to me is usually the stuff that has the most interesting results, right? Like GPU rendering is easy and the results are almost always, you can kind of guess what they're going to be for the most part. There's not very often surprises there. Likewise, engineering, most everything is single threaded unless you're talking simulations or rendering.
Okay.
So not super interesting. Photogrammetry is the weird one where multi-threaded up to a point, but then some of the applications don't benefit beyond a certain point. The GPUs in some of them, multi-GPUs good, some multi-GPUs not. That's probably the most interesting stuff to write about. And it's also the benchmarks that I actually put together myself, whereas like the engineering one's one of them Matt put together and I've just been maintaining. The other one's a public benchmark that we use for Revit.
Oh,
All the rendering engines are all public benchmarks from those rendering engine makers, the software developers. But the photogrammetry ones we actually had to develop in-house, and I did those. So that's probably both what I enjoy the most and also what is the most annoying, because then if anything goes wrong, it's my own fault. and things do from time to time do that.
Sure.
Plus, we're maintaining the benchmarks. So every time there's a new version, we have to see if our benchmark still works with it. And if not, tweak things and whatnot.
Yeah.
So,
yeah. I do not envy you that, I have to say. Software development was fun when it was a hobby, but to constantly, it's a frustration when something changes from one version to another and they move some menu to somewhere else or whatever. Just I can.
Yeah. Of the three programs we test, Pix4D is definitely has the least changes, it seems like, over time, which I appreciate. And we've got a good relationship with them. I've got some context there. Metashape was changing almost every version because we use Python scripting for that. They have a built-in support for Python scripting.
Oh, that's nice.
They would change what parameters their various commands would work with every version for a while. The last couple versions have not changed that, so I appreciate that. But they've also got a really good support team. So we've been, as far as email goes, been able to get a lot of good stuff there. The one that kills me is reality capture. There's very little support for like keyboard shortcuts and stuff.
Oh.
And they keep, so like I literally have to just be like, to get to a certain menu, just tab a certain number of times.
Oh, man.
And they would change how many options were in their menus constantly with every version. So that was kind of a pain, but that's.
Yeah. No. Is reality capture a fairly newer player in the
newer than Pix4D and Metashape for sure. Yeah. Metashape has been around for a long time. It used to be called Photoscan, and it's been years that it's been around. Pix4D has been around quite a while as well. Mm-hmm. Reality capture actually only just officially came out of beta a few months ago, I think. Sometime last half of last year is when it actually it had been around for a while, but it was, if you looked at the actual model, it was always beta at the end. So it actually came full release, and then they've had one major release since then. It's definitely a much newer program. Yeah.
Yeah. I remember when we first started to get into photogrammetry, or maybe it was a little bit before, but Photoscan was one that we played with to make a model of me, actually, at one time. That was fun. And it's, again, all of these, I'm constantly mind blown at what is possible. And back then, I mean, we're taking a bunch of still pictures of whatever it is and creating a 3D model from that. And that's amazing. Like the smarts, the science, the mathematics that go into having to, because I don't know. It's just, you start asking all these questions of like, how do they find like depth in what is essentially a two-dimensional image? And it's kind of guessing, I suppose, in a way, but man.
Well, I don't know all the math behind it by any means, but it all comes down to being able to see the same thing from different angles, at least with photogrammetry. That's the key thing. And then, you can, it actually, there's a point at which it basically just makes a depth map of whatever object or map or whatever it is that you're looking at, because that is a huge part of being able to reconstruct it as a 3D model, whether digitally or whether you're eventually printing that. Yeah,
it's super cool. I like that part of things a lot. It's like just the way we're able to leverage some of this technology is just mind blowing.
Yeah.
You know, the advancements in like GPU compute and things like that is just crazy. Like who man, it just takes such genius people to see these technologies like, oh, we have this hardware that's essentially built to draw triangles, but we're gonna make it do something else entirely, and it's just really neat. I like it a lot. That's cool.
There's some genius software developers out there that have come up with these things.
Yeah. So let's see here. So I'm kind of looking through our articles, and it looks like Still got some for the newer AMD graphics card, the 6900.
Yeah, my applications didn't have a lot of stuff on that because I think the only one is pretty much Metashape, because none of the GPU rendering engines, at least at this point, and I think this is probably something that'll start to change in the coming years,
Mhm.
but historically they've all been using CUDA, so
Oh,
pretty much NVIDIA only.
okay.
Octane has made some strides, I know, toward a more universal thing. Like they've got a version that works, I think, on Mac stuff nowadays, which of course is either AMD or just no dedicated GPU per se at all.
Yeah.
So I think the PC version doesn't yet support non-NVIDIA cards, but I suspect that'll be coming at some point.
Mhm.
But for now, on the GPU rendering side, yeah, we don't really test Radeon stuff because it doesn't work. And with photogrammetry applications, like I said, Metashape is the exception to the rule in that it does work with them. Reality capture and Pix4D need NVIDIA cards. And then on the engineering side, you can certainly use mainstream like GeForce and Radeon cards in those programs. They'll work to some degree, sometimes just fine. Other times you'll be missing features or whatnot. But the official support from like Dassault and Autodesk is usually just professional cards. So NVIDIA's Quadro and AMD's, I think they call them Radeon Pros these days. They've changed the name a few times over the years. It used to be Fire GL and Fire Pro and all these things. Anyway, so we don't tend to, like something like the Radeon 6900 XT isn't going to get tested in those applications here because we wouldn't really recommend using something that's not officially supported by the manufacturers.
I see.
So I didn't do a whole lot of that testing. But yeah, definitely Matt, for all of his Adobe stuff and DaVinci Resolve and everything, had those in his testing roundups. I think, what else have I done recently? We mentioned that we had a SolidWorks article in December.
Mhm.
The Agisoft SMT and multi-GPU performance stuff. There's been a lot. It's been a busy. It's been especially weird because of the rolling releases of all these GPUs. Like NVIDIA announced originally 3 30 series, 2 were available, 1 had to wait later. So we ended up with like this like rolling, here's an article on one of them, here's an article with the next one, and then the next one. And then they've announced 3060 Ti, and there keep being these swirling rumors about 3050s and 3080 Ti's, and who knows.
Wow.
It's all rumors, but
Did you see that picture floating around on Twitter for a 48 gigabyte VRAM?
Matt 39? Yeah. His trolling people on Twitter. I did see that.
That's fun. Actually, I'm curious your thoughts on the future going forward. Like, Apple's come out with their M1, their ARM chip, and that seems to be disrupting things quite a bit. I've seen a few articles, at least some testing surrounding Resolve, and that seemed to show some pretty good improvement in that space. I'm curious how you think that might affect the things that you've been looking at.
I don't know. It'll be interesting. Certainly, so M1 being an ARM chip means a completely different architecture, and on something like Apple, that's not horrible because they control the whole ecosystem.
Right.
So if they decide they're going to have a new version of their operating system that works on some other platform like ARM, and then that they're going to update all their own programs and encourage anyone who develops on their platform to do that, they kind of can more easily. They don't have to worry a ton about backward compatibility. And I'm under the impression they have a backward compatibility mode in there that sort of runs emulation for older stuff anyway.
Mm-hmm.
But even there's a vastly smaller software library of stuff that has ever run on Macs than on like Windows.
Sure.
So I know Microsoft has an ARM version of Windows that they've got for their tablets that have been around for a while. I've never used it, and I don't have any idea off the top of my head if it has any sort of emulation like that to run stuff. But to me, that's always been one of the big nice things about Windows is I can run a game or an application from like 20 or 30 years ago, and it still works.
Right.
So maybe if things go far enough, I wonder if we're going to end up losing some of that backward compatibility, which would be unfortunate. But again, at least competition is always good. I like that.
Mm-hmm.
I know the big thing with ARM, at least, well, I guess I don't know. My impression is the big thing with ARM is performance per watt. So use in like low power devices, tablets, laptops, where you need to save power if possible, is great. In a desktop, that's still nice, but it's not as big of a concern. You know, if you had a question of, okay, well, something uses twice as much power, but it saves me 20 or 30% of my time, probably worth it for most professionals, at least.
Sure.
And certainly, I don't think gamers are going to care a lot about using extra power if it means loss of frame rate otherwise. So I think it'll be a while before that like takes over completely. And I'm especially curious about whether they can crank up single-threaded performance high enough. It seems like ARM scales really well across multiple cores, which is great. But then so does x86 technology. But the processor clock speeds, at least, are nowhere near as high. And I don't know, it doesn't have to be high if the performance per clock is better. But just that maximum single-threaded performance is something that is still important in a lot of applications, like all those engineering things we discussed.
Right.
So it'll be interesting.
Yeah, that had crossed my mind because you were saying before about how like there's kind of a certain point where more cores is detrimental, and that's kind of the major strength with ARM is you can fit 1 million cores onto one little die. And so, yeah, that is going to be interesting to see how that gets resolved.
Yeah, that'll certainly be interesting. Let's see.
Oh, here's a good question from Twitch. Actually, Demon Mitt 1. He asks, he says, I've used the testing data and articles for years that are published by Puget Systems as really reliable data, but I've always wondered why under 3D design and animation, Puget doesn't include Blender within their testing suite.
So that's slightly more in Kelly's wheelhouse than mine now that he joined. But I can say that we don't currently use the Blender public benchmark because it is just a rendering benchmark. It doesn't actually test any of the other aspects of Blender. It purely tests rendering. And we've already got several tests that cover that. In theory, could add it, but it would just look exactly like either V-Ray or Octane or whatnot, depending on, I think it supports both CPU and GPU. So depending on which set of results you were looking at, it would be just like that. It's one of the reasons we dropped Keyshot a while back. It was at the time anyway, a CPU-only rendering engine, and we had V-Ray and Cinebench, both for CPU rendering. So we're like, well, we're just getting more of the exact same result. We already know if it's a CPU rendering engine, a couple of these tests will give us sufficient results. And that's why we have, I think, 3 GPU and 2 CPU rendering engines that we test. So that's the reason we don't use the Blender public benchmark. There's a lot of other stuff you can do in Blender, and someday maybe we will develop our own testing for those other aspects. I wish their public benchmark tested stuff like modeling and physics and things like that.
Yeah.
That's the stuff that I think is harder. It's real easy to test rendering. You just have to have a scene, press render, count how long it takes.
Right.
So that's the low-hanging fruit that would be easiest to do. But the other stuff is where things I think can get more interesting, especially physics is something that there aren't really, that I know of anyway, any great benchmarks out there for how the physics stuff behaves in like Blender or Cinema 4D or Maya, 3ds Max, those sorts of things. Yeah. So, yeah,
I know it has come up quite a bit. I wonder if, well, 2 things. Demon, if there are any particular aspects of Blender that you're interested in having tested, I'm sure we would appreciate that input. But also, push on Blender to whoever it is that makes Blender. I'm not sure. Push on them to change their benchmark too. To have those features implemented, because it's clear that there's a need. If one person is saying it, there's going to be others who are needing it too. So let's see. We have this question might be a little outside your wheelhouse, William, but I'm going to toss it up here anyway. Leonard Dog 27 asks, is it possible to do GPU manifold alias G-pipe for machine learning with the new models, and what more hardware is needed?
I don't even understand about half that question. I'm honestly not sure. Manifold. ML machine learning stuff is definitely not my wheelhouse. Ask that question again when Don's on here, and he might understand.
I was going to say, I think we have Don on next week. So yes, Don will be here next week. Ask him. Yeah, but I did want to toss that out there because it seemed fun to say. Let's see. Demon goes on to say, yeah, Peter's in-house Adobe Suite benchmarks are really great. It would be very neat to see someone like that come to Blender one day, because there's not a great source for really in-depth Blender testing. Yeah, and that's definitely something that'll be more in Kelly's wheelhouse if we end up including Blender. He's currently working a lot on Maya and 3ds Max, and then Unreal Engine, I believe. So starting kind of there, and then we'll see where it goes. One of the nice things, I'm hoping anyway, that it's kind of like the engineering applications where like we test SolidWorks and Revit, but we know that most of the results there also cascade down to Inventor and AutoCAD and things like that. So we don't have to test every single one of them. So hopefully, I would hope it's the case that 3ds Max and Maya, the way those behave, would kind of inform Blender for the most part. Mm-hmm. But I could be mistaken. Yeah. I'm curious, is there... This kind of is related to Demon's question. Is there any sort of softwares that you think like it would be nice to test that we just can't or aren't, like they're just not used enough, or just we never really looked into?
Well, for a long time, 3ds Max, Maya, and then the game dev stuff like Unreal and Unity were kind of what we wanted. We knew that there wasn't really any great testing out there. There's been some stuff for 3ds Max and Maya with Spec Perf, I think, but they often are a few years out of date on their testing, unfortunately, and it's expensive testing. The benchmarks they charge money for. So those are ones that if you'd asked me that a year ago, I would have said those, but now Kelly is working on those, which is great. Blender is definitely another one that we've had people ask about. Goodness, what else? There's some other engineering ones that have come up a few times. Creo and I can't remember. I used to get more of that when I worked in consulting. You know, people would ask about software that we didn't necessarily have testing for. But it's been several years now that I've been out of that, so I can't remember as many of those specifically. But I mean, really, there's tons of programs out there. We're never going to be able to test all of them, but right. Hopefully we're trying to hit enough of a representative sample that we can at least have a good idea of what will work well for other applications. I know on the editing side, there's Sony Vegas. Well, might not be Sony anymore, but Vegas Pro.
Vegas, yeah, I know that one's coming up quite a lot.
Yeah, that one comes up a lot, and then there's a couple competitors to like Lightroom and Photoshop that come up from time to time as well.
Yeah.
Capture One, I think, is one of them. So
that one.
Yeah, lots of stuff out there that would be cool to test, whether we end up having the resources to devote to it or not.
And I wonder though, like how much different it would really be, especially when it comes to like, say, a photo editing application. Our own testing of Photoshop and Lightroom doesn't change much from generation to generation. So like, I'm curious to know how, not that it'd be worth putting a lot of effort into, but how different could they really be?
Yeah, I don't know. It's something that, like I said, I have no idea if we'll ever have the resources to pour into that many different applications, because it would be nice if it was just to pour in some resources, do the testing, and be done, but it isn't. It's maintain all of that testing because new hardware comes out, updated versions of software come out. So there's probably only so much that we'll ever be able to really cover in the depth that we'd like.
Yeah.
But also, we might cut things over time. I mean, if it turns out that over years and years, Photoshop and Lightroom really don't need that in-depth of testing, we can kind of know what they need, maybe we cut them. Or the same thing for potentially like photogrammetry programs. If we get to the point where we really know how they behave, we don't necessarily need to constantly test the hardware.
Yeah.
So we'll see. But yeah, there's lots of good programs out there. I wish we could test them all.
Yeah. This one's interesting. I think might be related. So Outland on YouTube asks, is local solving in Fusion 360 even a thing? Any idea if it would be quicker than cloud solve on something like a 3960X, 3970X?
So I'm not specifically familiar with Fusion, but I know when Autodesk throws that 360 name onto things, that usually means that's the online version of something.
Mm-hmm.
Actually, a few years ago, that was one of the photogrammetry programs we were going to do, was an Autodesk one, and I don't even remember what they called it now. But just as we were about to publish the recommended system for it and all that, they switched it over to a new version that was exclusively cloud processing. It didn't even have the local option anymore. So we were like, well, there that goes.
Yeah.
Fusion 360, I'm not sure about, but it looks like, just from a quick glance, that's primarily cloud based. I don't know. There were some of those. It's been a while since we tested, but Pix4D, for example, has a cloud option. You can process in the cloud, but at the time anyway, we tested that, and it was not as fast as a good workstation locally would be. So in my personal opinion, with a lot of that cloud stuff, the questions sort of become threefold. One, are you just in a situation where you're on a budget and can't afford or can't get a hold of a high-end computer? Then on the occasions that you need to do higher processing, something where you can just, like a pay-as-you-go option, if they have that sort of thing, can be a good way to utilize the cloud to get performance when you need it, but not have to pay for it the rest of the time. But additionally, you need to be sort of cognizant of security stuff. Cloud vendors and whatnot are not perfect when it comes to security. So anything that is, some sort of, I want to say terms like high security, but like the classified, obviously, most of us aren't dealing with anything that's like military classified stuff, but there's certainly things that, your company might have, or that you're working on for another company, where if you were to let that slip, you'd be in legal trouble.
Oh, sure.
So dealing with stuff like that, I recommend keeping it all local on your own system. Ideally, in some of those cases, even disconnected from the internet, a air-walled system. So that's a factor. And then thirdly, really just a question of usability. So for certain types of applications, a lot of data has to move around. Mm-hmm. And if you're doing that with a cloud-based program, even if you have a fairly fast internet connection, it can be way slower if you're having to wait to upload gigabytes of video footage to the cloud, then do the edits, and then potentially download that when you're done. Okay, great. Even if it's just as fast in the cloud, you've added that extra time of transmitting data on both ends. Mm-hmm. And that certainly can be the case with anything with large data sets. So photogrammetry often has data sets in the tens of gigabytes. Video editing, it's not as big of an issue usually with modeling. That stuff is usually described sort of mathematically and can often be fairly small file sizes. Mm-hmm. But then like if there's texture data, that can get bigger.
Sure.
And it all depends, but that's definitely something to consider. If what you're doing might be just as fast in the cloud, but you're adding more time waiting on internet, or if you're in a situation where maybe internet's spotty or not reliable, or it's just slow where you are. I mean, I've been lucky to have gigabit internet for a while now, so I'm kind of spoiled. But I know that's not the case for everybody, and that's definitely something to consider with cloud stuff as well. So there's a lot to think about.
Yeah, and even if you do, even if you do have the best you can possibly get, like 1-2 gig internet, like when you're talking 160 or maybe hundreds perhaps of gigabytes, that's still going to take a while. Like it's no joke.
And it's not just your internet connection either. It's whoever you're sending it to. So there have been plenty of times when I'm trying to download or upload something and I'm like, I'm only going at a tenth of my speed here, buddy. What's going on your end?
Yeah, that's the killer. Is it's you both have to be on the fast highway.
Yeah.
Sure. And actually, that does bring up an interesting kind of broader question about the cloud. There does seem to be it isn't super big yet, but there's definitely a push for cloud-based services in this way. How do you feel about that?
I suppose partially because of where we work, and also partially just because I like to tinker with computer hardware. I always tend just to favor local stuff. I think just as my own bias, but there's definitely places where cloud computing makes sense. It's certainly been convenient. For example, I mean, it's not computing so much necessarily, but things like streaming of movies and whatnot is super duper convenient as long as you have an internet connection that's above a bare minimum. Netflix and all those things are super useful. We all do that nowadays, YouTube and whatnot. So there's a place for that, for sure.
Yeah.
I think though that it just needs to be tempered. I know there's over the last few years oftentimes a big push and keywords being thrown around about cloud computing and whatnot, but there's still something to be said for owning your own hardware, not having to worry about whether an internet outage or the vendor that you're working with having some weird problem and bug on their end. Are those things going to keep you from working? Because at least for me, my local system, if it goes down, I can fix it. I can actually do something about it. I can't fix my internet connection if it is screwed up. I can't fix Google if their cloud service is acting up. So I still have a bias toward the local stuff myself.
Yeah, and there's always the big specter of what happens when the service shuts down. Like if Steam, if Valve ever goes under, what are we going to do? But I mean that applies to other companies and cloud services as well. It's like if you have built, say, your whole company is from the foundation on a cloud rendering service, and Amazon decides that they're not going to do that anymore, or they're not going to support them on their AWS, what are you going to do?
Yeah.
To me, that's the biggest fear or the biggest consideration is like these companies may not always be there, or they may not always be online, or and then what?
Yeah, that's absolutely true.
Yeah. Let's see. There was some mention about ZBrush as well.
Yeah, that's another one. All that sort of stuff. Kelly is going to be far more familiar with those sorts of tools. I know what they're used for and have never touched them for the most part. So not particularly my wheelhouse, but again, it's really also going to come down to what we can have the time and resources for. Kelly's an awesome guy. He's doing some really cool work, but I know he's not going to be able to support 13 or 14 different applications at once or anything. So
just the work being done in Unreal is massive already. Yeah. And so, yeah. I am curious though, looking forward, like what are you hoping for and excited about for the next few years, as far as hardware, software, and just the overall landscape?
Well, I think the competition is great. First of all, so both Intel and AMD on the CPU side and NVIDIA and AMD on the GPU side being competitive with each other is really good. For a while, NVIDIA had been far enough ahead on the video card side that I think there was the potential for them to get complacent. I don't know that they ever did. Intel definitely a couple times in their history has gotten complacent, and both times AMD has shown up and kicked their butt a little bit, and that competition is good. So I'm excited about competition. I'm a little worried that because there is such close competition now, they're launching things early, like when they just have a couple samples, they go ahead and launch, and then it looks great, but you can't get a hold of anything. And that's definitely been the case with almost all the launches in the last 3 or 4 months.
Right.
NVIDIA's GPU launch, AMD's GPU launch, AMD's CPU launch. I don't want that trend to continue, and I'm a little bit afraid that the level of competition encourages that behavior.
Mm-hmm.
If you don't have competition, you can sit back and be like, let's build up a reserve of product, launch when we have tons of it, and not have to worry. If you're competing with somebody, you want to launch before they launch their next product and try to get market share and mental market share of people before the competition can, even if they can't actually buy very much of your product.
Right.
So that's a bit of a concern, and I'm sure that's also exacerbated by supply chain issues. So I'm hoping that as things globally settle down over the next year or two, that will go away and at least be one less problem there. Beyond that, I've really been liking the direction that ray tracing has been going on the GPU side. I'm sort of on the fence about. I didn't get a 20 series GPU for myself because there wasn't a whole lot of ray tracing stuff in games, and at home anyway. I'm not personally doing any of this rendering or whatnot, so I'd mostly be for gaming at home. I might pick up a 30 series card. I'm tempted to, but I don't know. Might wait one more generation, just largely because of the availability stuff. This generation just might not make it worth trying to hunt down a CPU or pay extra for it or anything.
Right.
But I think that's cool. I like the extra eye candy that it offers in games and other real time applications. I think that's really neat. And those are probably the biggest things, I suppose. Yeah.
I'm personally curious to see what Intel does with the GPU.
It'll be interesting. I'm not holding my breath for anything there. My understanding is the first gen one is supposed to be intentionally kind of low end, and then like their second gen is maybe where things are going to be more at. But I don't know if that's just rumors that I've read or whatnot. We'll see.
As long as it doesn't turn into another one of those. What did they end up doing with those their first try at GPUs ended up becoming like a compute only card that wasn't all that. That's it. The Phi card.
And that sort of petered out after a couple generations too. So like, I definitely don't want a repeat of that. Intel, I think I have to imagine, I don't know this for sure. I don't know personally anyone that works there, but Intel is such a huge company that I think it's got to be hard. They've got their fingers in CPUs. They're trying to go for GPUs. They do chipsets. They do networking. They do Wi-Fi. They do so much stuff.
Yeah.
That it seems like it would be hard to do it all well.
Right.
And that's one of the cool things about working at a place like Puget is we're small enough that we don't have those problems of scale, and we can also be kind of picky about, like, we dropped laptops a few years ago because it wasn't a good experience for us or our customers, and we can do things like that. Imagine if Intel came out and decided they were dropping some I think they've done it a couple times, but if they were dropping some big category of their products, they'd have to answer to shareholders and all sorts of stuff. It's got to be difficult being a company that big, so, yeah.
And supercomputing too. Actually, I'm really curious to see, because I know like currently the top dog is an ARM based thing out of Japan, I think, and just that whole space is really interesting. I like seeing what people are doing kind of on because you don't often see, it doesn't become very mainstream until. But we often will see the byproducts of it, and that's always really cool.
Yep.
Yeah, I think that's very interesting. There's a comment about Intel's U.2 drives are amazing. That's an interesting one that maybe I'll talk to John about that one, because like, is that even going to be a thing anymore? I don't know.
We haven't seen a whole lot of adoption of it in desktops. Certainly, M.2 has kind of been M.2 is cool. It goes right on the board. It doesn't need any cabling. U.2, you still have a cable going to a drive that has to mount somewhere else, so it takes up more space in the chassis. But I think it is adopted more widely in like server and data center stuff. Probably because of that. In a server or data center, you want to be able to pull out a drive without taking the whole system apart an M.2, at least the way it's designed, isn't built for that. It's, goes into a little tiny slot on the motherboard. So I bet the U.2 stuff is more integrated over there. Internally, under the hood, my impression is the M.2 and U.2 is effectively kind of the same thing. They're both PCI Express connections directly to a drive. And I'm not at all surprised that Intel would have good drives there. For years and years, when SSDs were brand new, Intel was like the go-to drive. And that's, I think I've still got them running in several of my systems at home. It's a little hard to keep track of. I have 4 computers plus a laptop. So, so 2 gaming systems for the kids, a home theater PC, my gaming system, my wife's laptop.
There you go. Dang.
So some of them are still running Intel drives. The others have Samsung drives because they still make desktop drives, but they stopped like making their own controller for it and stuff, I think, a while back. So we ended up at some point moving over to Samsung, which has also been great. But I'm not at all surprised that Intel would still be making good, especially server side stuff. Intel's always done really well on the server and infrastructure side of things, even when they've let their desktop stuff languish a little bit sometimes.
Yeah. And that's another thing I think people forget is like, they'll complain like, oh, how come Intel hasn't, how come they're still on 14 nanometer or whatever? And it's like, well, because they probably don't really care a whole lot about the consumer side when they're doing real well on the heavy iron side of things. So,
yeah,
maybe.
And it's again one of those things where there's so many different little sections that their company's doing that, yeah, I know from a gaming perspective, everybody thinks, oh, well, they're Core Series processors, but that's probably a teeny tiny part of what Intel as a company does. Yeah.
Well, all right. That does bring us a little bit over our hour. Is there anything else you'd like to mention or highlight before we say goodbye?
Nothing that I can think of. I just hope everybody has a good 2021. Hopefully it's better than last year, at least. That would be something.
Fingers crossed. It's been a wild week to begin. So, yeah. But yeah, okay. Well then, thank you very much, William, for taking time out of the day and joining us for our Labs Open Office Hour. And thank you to the audience as well for joining us again for our Labs Open Office Hour. We do this every week, Wednesdays and Fridays at 1 p.m. Pacific. Wednesdays, we bring in outside industry experts to talk about their process and workflow and all that good stuff that gets you guys some answers from folks who are deep in the trenches of the content creation and other aspects of the things that we focus on as a company. And then on Fridays, we bring in folks like William, our labs team, to talk about more about what we do on the inside and the crossover of the software and hardware that we test. So mark your calendars, Wednesdays, Fridays, 1 p.m. Pacific. And yeah, we'll see you all next time.
See ya.
Bye.
Bye-bye.